Hello students, welcome to Diksha Karnataka YouTube channel. So all of you guys, there is most of you guys gonna take NEET exam, right? The NEET exam is on 5th May, right? So in this video, I'm gonna discuss the preparation and the last 10 days strategy for NEET physics exam. Okay, so yeah, let us discuss. So there are high weightage topics and low weightage topics. Okay, so high weightage topics or chapter. Okay, so the chapter, I mean the questions more than, okay, they are going to ask more than 5 questions in this chapter. Okay, sorry, more than 3 questions, 3 or more than 3 questions. Okay, so those are high weightage topics, and low weightage topics are the chapters they are gonna ask 2 or 3 questions. That's it. Okay, yeah. So let's see what are the high weightage topics for NEET. The first one, moving charges and magnetism. So if you look at previous year question papers, or if you analyze previous year papers, so here they asked minimum 3 to 4 questions from this chapter. Okay, and then current electricity. In current electricity, every year they asked again 4 to 5 questions. Okay, 4 to 5 questions from this chapter. The third chapter, okay, the third one is rotational motion. Again, they asked minimum here 3 to 4 questions from this chapter. And then electrostatic potential and capacitance, and they asked 2 to 4 questions. Okay, some year they asked only 2 questions, and some year they asked 4 questions from this chapter. Okay, including gravitation also. Okay, I will tell you why I have included gravitation. Okay, so the fifth one, semiconductor electronics. Again, this one is also very high weightage chapter, right? So every year they ask minimum 3 to 4 questions from this chapter. And then units and dimension, units and measurement. Again, they ask minimum 3 to 4 questions. Okay, and the seventh one, the alternating current. Here they ask 2 to 3 questions. Okay, 2 to 3 questions from this chapter. And then nuclei. In nuclei, they ask 4 to 3 questions. Sorry, 3 to 4 questions. Okay, and the last one, ray optics. In ray optics, they ask 4 to 5 questions. Okay, yeah. So now these are the low weightage chapters. Okay, so kinematics, 1D, 2D, and circular motion. So in kinematics, 1D, 2D plus circular motion, they ask minimum 2 questions. Okay, 2 questions from these chapters. Okay, and then WEP and NLM, that is work energy power and Newton's laws of motion. They ask 2 questions, minimum 2 questions from these 2 chapters. Okay, and then EM waves, they ask 1 question. Okay, they ask minimum 1 question from this chapter, especially from a particular topic. Okay, I will tell you what are the topics you have to read in these chapters. Okay, next, electric charges and fields. In electric charges and fields also, they will ask 2 questions. Okay, 2 questions from this chapter. And then atoms, again they will ask 1 to 2 questions from this chapter. And then the mathematical tools and vector, they ask 1 question. They ask 1 question from this chapter. Okay, either they will ask question based from mathematical tools, or they will ask question from vectors. Okay, especially based on the parallelogram of vector addition and triangle of vector addition. Okay, especially in vectors. Yeah. Next, EMI, that is electromagnetic induction. They ask 1 question, 1 to 2 questions from this chapter. Okay, and next, wave optics and oscillation. Again, they will ask here 2 to 3 questions from this chapter. Okay, wave optics and oscillation. So why I have included wave optics and oscillation both chapters? Because these two are similar. If you know the oscillation, you can easily understand wave optics. Okay, yeah. Okay, so these are the high weightage and low weightage chapters. Okay, okay. So from day one, what are the chapters you need to focus on? Okay, so this is the day one. Okay, day one. Day one. Okay, so the first one, moving charges and magnetism. Okay, in day one, what are the chapters you have to read? The first one, moving charges and magnetism, and kinematics, 1D, 2D, and circular motion. Yeah. Okay, I will tell you what are the topics you have to read in moving charges and magnetism, right? In moving charges and magnetism, the first one, the charges moving in a uniform magnetic field, right? The charge or the charged particle moving in an or in a uniform magnetic field, in a uniform magnetic field, right? So when charged particle moves in a uniform magnetic field, what happens? It takes circular path, right? Isn't it? It takes circular path. So now here, in that case, you need to know how to find the radius of the circular path, okay? And then you should know how to find the mass of the particle, okay? And all, okay? There are new many formulas, right? Isn't it? You should know all those formulas. It will be very helpful, okay? And then the other thing, anyway, cyclotron is uh, deleted, right? Isn't it? Cyclotron topic is deleted, isn't it, from NEET? Okay, and then next you should know this one also. Here, this is the magnetic field, and the charged particle enters into a magnetic field, making an angle theta with the magnetic field. Okay, then what happens? What kind of path the charged particle will takes place, right? The helical path, right? And you should know how to find the pitch of the helical path, right? And then the radius of this circular path and all, right? Isn't it? Yeah, that's it. So pitch is this one, right? This distance. This is pitch, right? You should know how to find pitch and all. Okay, understood? Yeah. And what kind of question they are going to ask? Mainly they are going to ask question based on this one, finding the radius of the circular path, right? Suppose alpha particle and proton enters into a uniform magnetic field with same with same momentum. So what is the radius of the circular path taken by alpha particle and proton? You need to find the ratio and all, right? Isn't it? And then otherwise they will ask you to find what is the ratio of the kinetic energies of these two particle and all. Okay, yeah, that's it. Okay, so from this, only from these topics they are going to ask minimum 3 to 4 questions. Okay, yeah. And then you should know how to find the frequency of the charged particle also. What is the formula of the frequency? Time period is t equal to 2 pi m divided by qb, right? And the frequency is 1 by t, right? Isn't it? That's it. There are, I think there are only 6 to 7 formulas are there. Okay, 6 to 7 formulas, maximum 10 formulas are there. Okay, remember all those formulas, it will be very helpful in NEET. Okay, yeah. The next one, the low weightage chapter, kinematics, 1D, 2D and circular motion. Anyway, relative motion is also there, right? Here relative motion is also there, but in relative motion they are not going to ask riverman problem and rainman problem, right? Isn't it? They usually do not ask a riverman problem and rainman problem. Okay, they only ask basic relative motion question. Okay, kinematics 1D 2D plus circular motion. Okay, you should read in first day, first read kinematics 1D 2D and circular motion. If you read after reading this, okay, then read moving charges and magnetism. Okay, so how do you read? I mean, how much time you allocate for low weightage chapter and high weightage chapter, right? So if you read, or if you are allocating 2 hours, 2 hours for physics, okay, 2 hours for physics, so 70% you should focus on high weightage chapter, okay, and then 10% you should focus on, sorry, the remaining percent, 30% you should focus on low weightage chapter. Understood? And solve previous year problems also. Okay, solve previous year problems also. Solve PYP, previous year problems. Okay, or PYQ, previous year questions. Understood? Yeah, previous year problems or previous year papers. Okay, so in kinematics 1D, what are the things you have to focus, right? So the first one, 3 equations of motion. Okay, before that before that, you should know the meaning of instantaneous velocity. Okay, average velocity. Actually, average velocity you should read first, right? First average velocity comes and then instantaneous velocity. Average velocity, instantaneous velocity, okay, and then displacement, distance, right? Displacement, then distance. After reading displacement and distance, you should start to read average velocity, instantaneous velocity. So after that, you should know the meaning of average acceleration and instantaneous acceleration. Average acceleration and instantaneous acceleration. Okay, the most of the time they are going to ask, I mean in NEET, they are going to ask in kinematics one day, they are going to ask question based on these topics: instantaneous velocity, average velocity, instantaneous acceleration, average acceleration, then displacement and distance. Okay, displacement and distance, you should know the meaning. Okay, you should know the deep understanding, because if you know displacement and distance, you can easily understand instantaneous velocity, average velocity, instantaneous acceleration and average acceleration. Okay, and what is instantaneous velocity? Dv by, sorry, ds by dt, right? ds by dt. Average velocity is delta s by delta t, right? And instantaneous acceleration is here dv by dt. Okay, and you know, right, we can also write acceleration in terms of x, right? How do you write? Acceleration a equal to v into dv by dx. Okay, they asked question based on this formula. Okay, if previous year paper, they asked question based on this formula. I think in 2015 or 16 they asked the velocity of the particle v equal to something 2 alpha x to the power something 2n minus 2n something. Okay, you have to find the acceleration of the particle, okay, at some distance x. Okay, so how do you solve? Apply this formula, you will get the answer. Okay, so they will ask question based on these four topics. Okay, and then in 2D it is circular, sorry, it is this one, right? The projectile motion, right? You should know the formulas of the projectile motion. Okay, next, the projectile motion, right? Projectile motion, remember the formulas. Okay, formulas. They will ask direct question based on the projectile motion. Okay, and then circular motion. Again, in circular motion also, remember the formulas. What are the formulas? That one, v equal to omega into r, right? Omega vector cross r vector. And then you should know the tangential acceleration, angular acceleration and all. Okay, and then centripetal acceleration, right? AC, right? AC equal to v square divided by r, right? AC equal to v square by r. Tangential acceleration and centripetal acceleration, AC equal to v square by r, and so on. Okay, yeah, so these are the things you have to focus on, focus more on these topics. Okay, so first day, this is your challenge. Okay, you have to read all these topics. Okay, and then the second day, current electricity. Okay, you should read current electricity and Newton's laws. Low weightage chapter is Newton's laws of motion and work energy power. Okay, so in current electricity, what are the things you have to focus, right? So the first one, drift velocity, right? Drift velocity, right? The first thing you have to focus more on drift velocity, and then the second one, mobility. Second one, the mobility, right? And then the here, the relationship between drift velocity and current, right? Relationship between, right? Relationship between drift velocity and current, right? And then again the relationship between mobility, drift velocity and current, right? And then the third one, Ohm's law. Ohm's law. Okay. Ohm's law, that is V equal to IR. Okay. Anyway, color coding of resistance, that is eliminated, right? And potentiometer is also eliminated. Potentiometer, meter bridge is also eliminated, right? No, I think potentiometer is eliminated. Meter bridge is not eliminated, right? Okay, focus more on Ohm's law, right? In Ohm's law, you should know the definition of, sorry, you should know the expression of resistance, okay? Expression of resistance, R equal to rho L divided by A, okay? That one. And then temperature dependent on resistance, right? That is R T equal to R naught into 1 plus alpha into delta T. So they asked question based on this one, right? This year CET, isn't it? So remember, they have given meter bridge, right? And they gave resistance at 0 degree Celsius and 100 degree Celsius and 400 degree Celsius. You need to find the resistance, right? Isn't it? So here you should focus on these topics, okay, in current electricity. After that, the combination of resistance, right? The fourth one, combination of resistance. Combination of resistance. Okay, combination of resistance. That's it. Okay, you should focus more on these topics. And then Wheatstone bridge is also there. Okay, in Wheatstone bridge they will ask very easy question. Okay, they will ask you to find equivalent resistance between A and B. They will give you Wheatstone bridge, right? Isn't it? Or else in CET they have asked these kind of question, right? Here they have given Wheatstone bridge, right? To Wheatstone bridge, right? So you need to find the current passing through the wire, right? Isn't it? Or current passing through the circuit, isn't it? So this one is R, 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 and this will be 2R, 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 and 2R. You need to find current passing through the circuit, right? Isn't it? They will ask these kind of questions only. Okay, very easy question. So this one is balanced, so these two will be neglected, right? So then find the equivalent resistance between point A and B, then find the current, right? Isn't it? So they will ask these kind of questions only, okay, from Wheatstone bridge. Wheatstone bridge, right? And then low weightage chapter, work energy power and NLM. Okay. So in work energy power, what are the things they are going to ask, right? So mainly they are going to ask mainly the question from work, okay? The work W equal to F into dx, okay, or F dot dx, okay? So they will ask question based on vector form also and scalar form also, okay? And here also they will ask question based on variable force, okay? That is, they will give you force versus x graph, okay? X graph like this, okay? So they will ask you to find the work done by the force when it moves 15 meter distance something, okay? So now you have to find the area under this curve, right? That's it. They will give you the force value also. Find the area under this curve, you will get the answer, right? Yeah. So mainly they are going to ask this question based on work, okay? Energy, yeah, conservation of energy theorem. They will ask question based on conservation of energy theorem, okay? Conservation of energy theorem or conservation of mechanical energy theorem, okay? So that is initial total energy equal to final total energy, okay? Yeah. In NLM, what are the things they are going to ask, right? They are going to ask mainly from second 3 Newton's laws of motion, okay? 3 Newton's laws of motion, right? Especially from second law of motion, okay? Second law of motion, okay? That is, you should know how to draw the free body diagram and all, okay? If you know how to draw free body diagram and all, then you can easily solve most of the question, right, from the rotational motion, right, and work energy power also, right, isn't it? So they are going to ask question mainly based on second law of motion. Okay, drawing the free body diagram and calculate the acceleration, right? And then here friction is also included. Okay, friction is also included. You should know static friction. You should know the difference between static friction and kinetic friction. Okay, the third one, static friction and kinetic friction. Okay, you should know the difference between static friction and kinetic friction, and you should know the direction of the friction acting between the surfaces. Okay, yeah, that's it. If you know that thing, then you can easily solve any question. Okay, yeah, most of the question, not every question, most of the questions. Yeah, next one, day 3. What are the chapters you have to read? So in high weightage chapter you have to read system of particles and rotational motion, right? Anyway, we have read units and dimension, sorry, we have read kinematics 1D, 2D and circular motion, right? We have completed in day 1, we have completed 1D, 2D and circular motion. In second day we have completed work energy power and NLM, right? So if you know the basic understandings of all these chapters, then you can easily solve most of the questions from system of particles and rotational motion. Okay, in system of particles, what are the chapters you have to read? The first one, center of mass, right? Center of mass, they will give you the particles and position of the particles also. You have to find the center of mass of the system. Okay, so that is the discrete system, right? In continuous system, they will give you one function. Okay, so you have to integrate from you have to integrate and you have to find the center of mass, right, isn't it? You should know the basic definition of the center of mass. Okay, and then the momentum. Okay, momentum. Okay, so in momentum you should know how to apply conservation of momentum theorem. Okay, conservation of momentum theorem, that is initial momentum equal to final momentum. Okay, initial momentum equal to final momentum. Understood? So focus more on these two topics in system of particles, that is center of mass and momentum. Okay, and focus on applying conservation of energy theorem also. Okay, and then the rotational motion. In rotational motion, you should focus more on finding the moment of inertia of the body about any axis. Okay, about an axis, any axis. Okay, finding the moment of inertia, finding the moment of inertia. Okay, second one, finding torque, finding torque tau. Okay, what is torque tau? Tau equal to r cross f, right? Or torque tau equal to I into alpha vector, right? Yeah, you should know the basic understanding of moment of inertia, finding the moment of inertia of the body about an axis, and then finding the torque acting on the body, and couple also, right? Couple also. Okay, and then they will ask question based on the third one, equation of motion. Okay, question based on equation of motion for particle which is moving in a circular path. So three equation of motion are there, motions are there, right? So what are the three equation of motion for rotating particle? So the first one, omega f equal to omega naught plus alpha into t, right? The second one, here theta equal to omega I into t plus half alpha into t square, right? The third one, omega f square is equal to omega I square plus 2 alpha into theta. They will ask question based on these three equations, equation of motion for circular motion, right? Yeah, that's it. Okay, and then they will ask question based on conservation of energy theorem. Okay, conservation of energy theorem for rotational motion, rotational motion. Okay, conservation of energy theorem for rotational motion. So here before applying the conservation of energy theorem, you should know how to apply conservation of angular momentum also, conservation of angular momentum. Okay, conservation of angular momentum. That is initial angular momentum equal to final angular momentum, right? So when do we apply conservation of angular momentum? When there is no external torque acting on our system, right? Yeah, that's it. These are the things you have to focus on. Rotational motion, okay, system of particles and rotational motion. Usually they are not going to ask question based on collisions, okay, mainly they are going to ask question based on these topics only. Yeah, in low weightage chapter you have to focus on EM waves, okay. EM wave, they will ask question, they will ask only one question, one or two question from the EM waves, okay. And most of the time they ask question based on pointing vector, right? So what is the pointing vector? Pointing vector S vector equal to 1 divided by mu naught into here E vector cross B vector, right? So they ask question based on pointing vector, or you can write C vector equal to E vector cross B vector. They ask question based on this one, okay. That is, they will give you the propagation electric field wave, okay, electric field wave. You have to find the magnetic field wave. That's it. They will ask question like this. They will give you electric field wave, okay, and they will ask you to find magnetic field wave, okay. And sometimes they will ask you to find what is the propagation of the wave, direction of the propagation of the wave, right? And what is the direction of the oscillation of the wave and all, okay. So most of the time they ask question based on this topic only. Most of the time, 90% of the time, if you observe or if you see the previous year paper, they ask question based on this topic, okay, pointing vector, pointing vector, okay. And then the second one, electromagnetic spectrum, electromagnetic spectrum. See, pointing vector comes in this one, right? Electromagnetic wave, conduction current, displacement current is also there, right? And they asked question based on refractive index also, right? The refractive index of the medium n equal to root of epsilon by epsilon naught, epsilon r here, epsilon by epsilon naught into mu divided by mu naught. These kind of questions they asked, okay. They will ask direct question, okay, but here they will ask bit tricky question. That's it, okay. If you know the vectors, you can easily solve these the question from this topic, okay. In electromagnetic spectrum, you should know the range of the every electromagnetic waves, okay. They will ask question based on that only, okay. This chapter only, sorry, this topic only, electromagnetic spectrum, okay. You should know the range, wavelength range, frequency range of the electromagnetic wave. You can easily solve any type of question from this topic, because they cannot ask tricky questions, right? Isn't it? I mean, they can ask, but it is not a very difficult question. It is not going to be a very difficult question, okay. You can solve this. So just remember all the range of the wavelength of every electromagnetic waves and frequency of the electromagnetic waves also, okay. Yeah, next one, in day 4 you have to read electrostatic potential and capacitance, gravitation. Low weightage chapter is electric charges and fields, okay. So electrostatic potential, capacitance, why I have included gravitation, right? See here, electrostatics and gravitation, both are similar chapters, okay. Both are similar chapters, formulas are also similar, right? In electrostatics you use charges, right? In gravitation you use masses, right? So here what is the force between the two masses? The force of attraction between the two masses, that is inverse square law, right? F is directly proportional to m1 m1 into m2 and inversely proportional to square of the distance between the m1 and m2. The similar thing for Coulomb's law also, right? Isn't it? Or Coulomb's force also, right? The electrostatic attractive force or repulsive force between the two charges is directly proportional to product of two charges and inversely proportional to square of the distance between them, right? Isn't it? So in electrostatic potential and capacitance, right, what are the things you should know? So the first one, the basic definition of the potential, right? So what is potential? Potential V equal to work done to bring a charge from infinite distance to a particular point per unit test charge, right? So that will be W external divided by Q, right? And you can write in terms of here this will be U infinity minus UQ, sorry, UP, okay. u infinity minus up divided by q. Okay, understood? Or ua, okay, or you can write it as here u2 minus u1 divided by q. Okay, u2 is the potential energy at infinite distance. Okay, potential energy of the charge at infinite distance. u1 is the potential energy of the charge at a particular distance, which is particular point, so which is near to the system of charges, right? So electrostatic potential, you should know the basic definition of the electrostatic potential, and then electrical potential energy. Okay, second one, electrical potential energy, u equal to q into v. Okay, okay, so in these two topics, what type of question they are going to ask? The question they are going to ask mainly based on the system of charges, finding the potential due to the system of charges and potential energy due to the system of charges. So what kind of question they are going to ask, right? Suppose they will give you three charges located at the corner of the triangle. Okay, they will ask you to find the potential at the center of the triangle. Okay, instead of triangle they will give you square. Okay, they will ask you to find potential at the square of the triangle. Similarly, similarly the four charges are at the corners of the square. Okay, corner of the square or rectangle. Okay, so they will ask you to find the work done to bring another charge from infinite distance to the uh, center of the square. Okay, they will ask these kind of questions only. Okay, similar questions, it is there in your modules or any books, it is there. Okay, and previous year problems also. Solve previous year problem, you will get the idea. Okay, proper idea. Okay, so then, okay, you know potential and potential energy, right? Okay, in capacitance, what are the things you have to read, right? So first you should know the basic definition of the potential capacitance, right? That is C equal to Q divided by V, right? So what is Q? Q is charge on the capacitor, V is potential difference, right? Or potential applied, or potential of the capacitor, right? Okay, and you should know the energy stored in the capacitor. Okay, you should know how to find the energy stored in the capacitor, and then heat dissipated, right? Energy stored in the capacitor, U equal to half CV square, right? Or U equal to half, there are different formulas, right? Isn't it? Instead of Q, right? You should know how to write, isn't it? Yeah, that's it. And then the combination of the capacitor, right? Second one, combination of the capacitors, combination of the capacitors. Okay, combination of the combinations of the capacitor. Okay, parallel combination, series combination, right? Combining parallel and series, combining combination, combined combination, right? Yeah, that's it. They are going to ask these kind of questions only. Anyway, they are till now they didn't ask, I mean they asked only one or two times question based on charge decaying and charge stored in the capacitor. Okay, yeah, that the formula is Q equal to Q naught into 1 minus e to the power minus t by RC, right? The charge stored in the capacitor at any time t, what is the charge stored in the capacitor, or what is the charge decaying in the capacitor, right? Yeah, so these kind of question they are going to ask. Okay, and they ask question based on these topics only. Okay, so in electric charges and fields, what are the topics you have to focus more on? In electric charges and fields, first you should focus, or you should read the properties of the charges. Okay, properties of the charges, properties of the charges. Okay, and then you should know the Coulomb's law, right? You should know Coulomb's law, Coulomb's law, and in vector form also, Coulomb's law in vector form. You should read Coulomb's law and Coulomb's law in vector form. Okay, and then force acting on a test charge due to a multiple charges, right? So the same thing you read in gravitation also, right? Isn't it? Gravitation and electric charges and field, these two are combined. Okay, so do one thing, while reading this one, read this chapter also. Okay, because both are similar, right? Isn't it? And then here Okay, in gravitation, what you do? Instead of using charge, you use mass, right? That's it. I don't need to write everything, right? The same formula you should know the meaning of gravitational potential and gravitational potential energy and all. And the extra thing you have to focus more on acceleration due to gravity, right? That is variation of variation of variation of g g due to height and depth, due to height h and depth d. Okay, height h and depth d. That's it. That is the extra topic you have to read. Okay, otherwise everything is same, right? It's the same thing: potential energy, the gravitational potential and gravitational field and all, right? Okay, Coulomb's law and Coulomb's law in vector form. And the third one, right? You should know the basic definition of electric field, right? Electric field basic definition, basic definition, right? Electric field basic definition. And then they will ask question based on the electric field lines, right? Electric field lines. Okay, you should know the properties of the electric field lines. Understood? And you should know the basic definition of the electric field, and you should know how to write in vector form. Okay, how to write electric field in vector form. Okay, and then the fifth one, okay, electric field in vector form. And then yeah, that's it. Okay, you should read all these chapters, okay, all these topics in electric charges and fields. Okay, understood? Yeah, and you should know the conductors and dielectrics also, but they are not going to ask many questions based on those topics. Okay, yeah, that's it. And then day 5, what are the topics you have to focus on? Semiconductor electronics and atoms. Anyway, here in semiconductor electronics, most of the things are there, right? Isn't it? So the first one, diodes, right? Focus on diodes. Okay, diodes and logic gates. Logic gates are also there, and you should know how to find current gain, voltage gain, right? In transistor you should know, right? Transistors. Okay, so focus more on these 3 topics. Okay, they are not going to ask very tough question. Okay, focus more on theory and some question, numerical question. Solve previous year paper, you will get to know. And in atoms, what are the things here you should know, right? So the first one here, the Bohr's, they are going to ask question mainly based on the Bohr's atomic model. Okay, Bohr's atomic model. Understood? So they will ask question mainly based on Bohr's atomic model, that is the angular momentum of the electron, right? That is mvr equal to nh cross divided by 2 pi. Then energy of the electron in the orbit, right? In nth orbit, in hydrogen like atom, right? Isn't it? Hydrogen or hydrogen like atom. And then they will ask question based on the distance of closest approach also, right? Isn't it? Okay, in day 6, you have to read units and measurement and mathematical tools and vectors. So in units and measurements, you should know the dimensions. You should know how to find the dimension of physical quantity. Dimensions of physical quantities. Physical quantities, right? Dimensions of physical quantities. And then errors, right? Errors and measurement. You should know the types of errors, right? Types of errors and measurement, right? Okay, in mathematical tools and vectors, right? So till now they asked question based on vectors only. Okay, what kind of question they are going to ask? Mainly based on the triangle law of vector addition. Okay, triangle law of vector addition. And the second one, parallelogram of parallelogram law of vector addition. Okay, so they will ask question based on these 2 topics only. That's it. Okay, yeah. In day 7, you should read alternating current and EMI, right? So first read EMI, then go to alternating current, because if you know EMI properly, alternating current is easier to understand. right? So in EMI, what are the things you have to read, right? So in EMI, you should know the Lenz's law, okay, Faraday's law, Lenz's law, right? Faraday's law, Lenz's law, Lenz law, right? Lenz law, and then Faraday's law, Lenz's law, and then you should know how to find induced EMF, that is minus d phi by dt, right? You should know induced current, right? That's it. They will ask these kind of questions only, okay? And you should know self inductance, mutual inductance, okay? Yeah, they will ask question based on these topics. Only 4 to 5 topics are there, right? They will ask question based on these topics only, okay? If you know the formula, you can easily solve the questions. And then come to alternating current, right? In alternating current, they will ask you to find, okay, they will ask question based on LCR circuit, okay? LCR circuit, and question based on resonance, okay? So they will give you LCR circuit, right? L, C and R circuit, sorry, yeah, LCR circuit. So they will ask you to find potential difference across L, potential difference across C, potential difference across R, or impedance of the circuit, right? Or they will ask you to find phase difference, right? Phase difference. What is the phase difference between current and inductor, or current and capacitor, and then current and R, VR, right? Isn't it? And then you should know how to find phi, that is phase difference, right? Isn't it? And then you should know how to find quality factor, right? They will ask you to find quality factor, right? Isn't it? And you should know the formulas of the quality factors, right? Formulas of the quality factor, right? So there are many formulas are there, right? So remember all those formulas, okay? They will ask you to find quality factor. And then the transformer, okay? Transformer. There are two types of transformers are there, right? So the first one is step up and step down. Second one is step down, isn't it? Yeah, that's it. I mean, in transformer, they will give you two. They will give you the ratio of the transformer turn ratio. Okay, so you should know how to find the voltage in primary coil and voltage in secondary coil. Okay, and you should know how to find the current in the primary coil and secondary coil. And sometimes they asked rectifiers also. Okay, half wave rectifier and full wave rectifier. Half wave rectifier and full wave rectifier. Okay, rectifiers. They ask question based on rectifiers also, half wave and full wave. Okay, yeah, that's it. And day 8, what are the topics you have to focus on? So the first one, nuclei and wave optics and oscillation. Okay, so in wave optics, focus on Young's double slit experiment. Okay, Young's double slit experiment. Okay, in Young's double slit experiment, the qualitative analysis, okay, everything that is fringe width and maxima, minima and all, okay, solve previous year papers, okay, and then Fraunhofer diffraction, okay, Fraunhofer diffraction, okay, Fraunhofer diffraction, especially in single slit, okay, single slit Fraunhofer diffraction. And you should know how to find the minima, maxima, first minima, secondary minima, third minima and all, okay, and then first maxima, secondary maxima and all, okay, understood? Yeah, in oscillation, what are the topics you have to focus more on? So the first one, this one, right? The time period of the oscillation, t equal to 2 pi into root of L by G, or t equal to 2 pi into root of K by M, right? So how we got this equation? You know, right? F equal to K, XF is M into d square x by dx, d square x by dt square. From that, we will get this equation, right? Isn't it? So they will ask question based on this only, okay? In simple harmonic motion, in SHM, okay, okay, and then in waves, what kind of questions they are going to ask, right? In waves, they are going to ask the question from the velocity of the wave in string, right? Velocity of the wave in string, right? That is root of t divided by mu, right? Isn't it? And they will ask question based on velocity of the wave in medium, right? Isn't it? So they will ask these kind of question only, uh, and then the frequency of the nth harmonic motion, right? The second topic is frequency of nth harmonic motion, right? So when we will get when the string is connected to the one end, okay, right? When string is connected to the one end or the both end, right? So you should know how to calculate the frequency of the nth harmonic motion, right? Nth harmonic, not nth harmonic motion, nth harmonic, right? Yeah. Sorry. Next, nuclei, right? I think in nuclei radioactivity is deleted, right? Isn't it? Radioactivity is deleted, and they will ask very easy question, okay, based on nuclei. The first one, they will ask question based on isotopes, isobars, isomers, and all, right? Isn't it? So those are easy questions, right? And then they will ask question based on radius of the nuclei, radius of the nucleus, okay, nucleus, okay. They will ask question based on radius of the nucleus, understood? And then yeah, that's it. And then the reaction, nuclear reactions, they will ask question based on nuclear reactions, okay. Read these topics, okay. Nuclear reaction, that is fusion and fission reaction, right? And they will ask you to find, okay, next topic is binding energy. Binding energy, you should know how to find the binding energy and binding energy per nucleon, right? They will ask question based on binding energy per nucleon, okay. So focus on these topics, you will get to okay, you will get the idea, okay, what kind of question they are going to ask. Yeah. The last day, the ninth day, okay, not last day, uh last but one day, right? Or penultimate day. So here you should focus on ray optics, okay. Ray optics is bit a big chapter, right? Isn't it? Big chapter. So here in ray optics, uh the first you should focus on mirrors, okay. Mirror formula, mirror formula, okay. You should focus more on mirror formula, that is 1 by f equal to 1 by v plus 1 by u, right? And the spherical mirrors, right? Isn't it? And then focus on the plane mirror also, okay. So sometimes they asked question based on uh, velocity of the image, okay. Plane mirror is used, they will ask you to find velocity of the image, okay. Object is moving with some velocity, they will ask you to find velocity of the image, like this. Here mirror, okay, mirror is moving in some velocity v in this way, okay. Object is moving in this way with velocity v, they will ask you to find the velocity of the image, okay. What is the velocity of the image? They will ask these kind of questions, okay. First one, mirror formula, okay. And then in refraction, what kind of questions they are going to ask, right? So in refraction, the first one, apparent depth and real depth, right? Real depth and apparent depth. You should focus on real depth and apparent depth, okay. The formula is there, right? Mu equal to real depth divided by apparent depth. They will ask you, okay, so they will ask these kind of questions. The fish is there, okay, this is pond, okay. The fish is there, right? Here the bird is seeing the fish. What is the shift of the image of the fish, right? They will ask question like this, yeah. In refraction, okay, this one. And then the prism, right? Prism, okay. Prism, you should know the how to find refractive index of the prism, and thin prism also, okay. Thin prism also, thin prism and thin prism, okay. Refractive index of the prism, okay. And then how to find angle of minimum deviation of the prism, okay. And you know, right, how to draw the graph of angle of minimum deviation and angle of incidence, right? that one also. Okay, that's it. Okay, and the third one, lens. Okay, lens, you should know lens formula. Okay, lens, here lens maker's formula, lens maker's formula, and the second one, lens formula. Okay, lens formula, right, isn't it? And the magnification is already included. Okay, here the magnification is included. Magnification, it is included. Understood? Yeah, you should know lens maker's formula and lens formula. Okay, then combination of lenses. Okay, combination of lenses, combination of lenses. Okay, you should focus more on these topics in ray optics. Okay, okay, ninth day you have completed, half day, in half day you have completed ray optics, right? So then take 2 mock tests. Okay, ninth day 1 mock test. Okay, after that 1 mock test, ninth day mock test, and then 10th day another mock test. Okay, so then you are ready for the battle. Okay, understood? Yeah, so that's it. Thank you so much for watching this video. Okay, so if you love this video, please like and share. Okay, if you want to watch more such videos, please subscribe. Thank you.